Okay folks, here we are again at our Density of Unknown Solids lab. And again, the purpose of our running this lab is so that we can determine the density for all 6 of the unknown solids, and then try to use the density to determine if any of these unknowns are made of the same material. So this time we are working with the density of regular solids. And the process is very much the same. We're going to start by recording the mass in grams for each of these regularly shaped objects. So here we are looking at regular object 1, the cube, 2, the slab, and 3, this very thin sheet. What you should be doing now is making sure you are recording those masses in the Google Doc for our unknown solids lab. So you can see here that part 2, you should already have the irregular solids up here filled in. So right down here, the regular shaped solids, you're going to fill in the masses for the cube, the slab, and the sheet. Remember that you can pause this video at any time so that you can go to your Density of Unknown Solids lab document and type in the necessary data. Okay, once we have this mass typed right on in, we move on to calculating the volume for each of these objects individually. So in order to find the volume of a regular solid, we need to measure the length in centimeters, width in centimeters, and height in centimeters. Now for a regular solid like the 4 that we have, the easiest way to determine what is length, width, and height would be to pick one corner and measure the 3 sides along that corner. Once you have those measurements, you simply multiply those 3 measured sides together, and this is what gives us our unit of centimeters cubed, because you're multiplying 1 centimeter times another centimeter times another centimeter. Now a common misconception is people think that this cube value would mean that you multiplied any number before it 3 times, but you don't. The cube is solely referring to how many centimeters you multiplied together. Alright, so once you have recorded your length, width, and height for cube 1, you're then going to repeat the steps for the slab and the sheet. Now the sheet is a little difficult because it is very, very thin. So in the pictures for this sheet, I have given you what the width is based on measurements with a caliper, which is a measuring device for very small diameters and objects. So here we look at our pictures. This is a volume for cube 1. This is a centimeter ruler. I know it says mm right here. Millimeters refer to the tiny numbers, or the tiny slashes. Centimeters refer to the numbers you can read. Okay, so I'll give you an example. This very first measurement here, which is the length of our cube, we can see is at least 1, and we are 1, 2, and about a half. So this would be 1.25 centimeters. Okay, so now I want you to try to read the width and the height for the cube and type those numbers now into your length, width, and height for that object. Once that's done, you're going to take your calculator and multiply these 3 numbers together to calculate your volume. Again, remember, any of these measurements do not need to have units next to the numbers because the units are in the section headings above. Now once you finish recording the measurements for the length, width, and height of cube 1, we're going to move on to cube 2. Well, technically it's the slab. So slab number 2. Here's our length. What does this measure? Record it in the table. Our width. and then our height. Record those values and then multiply the 3 together to calculate your volume. Remember, you can pause this video at any time to record your measurements and to do your calculations. Moving on to sheet number 3, again, this number up here would be our length. So what is this recording? And then, of course, our width in this picture down here. And again, because the height, it's such a thin paper-like sheet, I am telling you right here that the height is 0.0051 centimeters. Plug in those measured values into your unknown solids lab document under our regularly shaped solids quantitative data. Make sure you're multiplying length times width times height to calculate the volume. Now, once we have managed to calculate the volume, it is all about figuring out the density for each regularly shaped object, and much like last time, you're simply taking the mass and dividing it by the volume, and then recording that in the data table for each of the 3 regular shaped objects. And just like in part 1, you're going to identify the metal for each of those regular objects by comparing the density that you calculated with the densities that you researched for common metals. Once you've done that, you should be able to now compare part 1 and 2 densities and see if any of these 6 objects might be made of the same metal. Alrighty, that's it for today, folks.